Hey everyone, this is Mr. Kier. In this video, we're going to be looking at graphing. So one of the first questions we should be asking is, why do we even bother graphing? So I have a set of data here, and it's the position and time for a vehicle traveling on the highway. So every hour, we documented the position of this vehicle. And you can see after the first hour, we traveled about 5 kilometers. Then we traveled 6 kilometers in the next hour. Then it's about 4 kilometers. Then it's about 6. So it looks like roughly, if you average it out, about 5 kilometers every single hour that we're traveling. But I don't know how consistent the data is, so we're going to be looking at graphing this data to really look at the trends to be more evident. So when you're setting up a graph, there are a few things you have to keep in mind. So number one, make sure you're plotting on graph paper. So it's really important. You want to make sure you graph accurately. And you have to keep in mind you have to set up the scales. Now when you're setting up the scales, things to keep in mind are this. Your scales in the X and Y are not the same. Very rarely are they the same in size. So it's very different than math, so kind of keep that in mind. You want to make sure that you've got consistent increments. So make sure that you're going up the same amount. And these increments allow you to easily plot the data. And you want the increments to allow you to have a very, very large graph on your graph paper. So let's look at the data here. Now, one thing to keep in mind, whenever you have time, you always put time on the x-axis. Okay, so we were graphing with time across here. So we have our time, and our time, the unit I think is in hours. And I think we're going up to, let's look at the data here, we're going up to 8. So let's look at what we have here and try to figure out a good increment to use. Looks like maybe around 10 here. So let's go 1, 2, 3, 4, 5, 6, 7, 8. Oh, looks like going up by ones is very effective here. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 here. So our graph will be going up to this point right here. How about in the y-axis? Well, in the y-axis, we're going to be graphing our position. So we're always labeling the axes, including units. So we measured position in kilometers. And we have a direction here too. We're going to be measuring from the north. So that's really important. So you have that direction always included. So include units and direction and label. So now for this particular set of data, it looks like we're going up to around 42.5, just shy of 50. Let's see what we can do. So I'm going to look at, can it go up by 10? So 10, 20, 30, 40, 50. That's a little bit too small. How about 5? 5, 10, 15, 20, 25, 30. It looks like it's going to work. So make sure that your data is, values are, increments are consistent. So make sure, don't go like 5, 10, 20. No, that's wrong because you're going by 5s and all of a sudden you're jumping by 10s. You have to be consistent. So it should be 15, 20, 25, 30, 35, 40, 45, and finally 50. So our data is perfectly going to fit in here, making this a nice large graph. And what we want to do is we want to start plotting the data. So when we're plotting the data, you carefully plot it step by step. So by data points, so 0 and 0.0, so 0 and 0. Okay, and then at 1 hour, I'm at 5 kilometers. At 2 hours, I'm at 11 kilometers. Again, I'm taking my time, and see my scale is really easy to read, so it's a very good scale. It's not awkward. I don't want to go up by like 7.5 or something strange like that. And then you keep going and you plot all of your data going across. I'll show you that in a little bit. The one thing to keep in mind is you always have to have a title for your graph as well. It's a descriptive title. We put it always at the bottom. Okay, always under the graph. Really, really important. And it starts with the word figure. You number it. So here we got figure 1. And look at the title. Position and time for a vehicle traveling on a highway. So you want to tell people what your graph is showing. It's showing the position over time for this vehicle. And if you look, hey, that's the same as the title on my table. Okay, now we've graphed the data. What does it look like? You should have a thing, a series of points that look like this. It looks like a reasonably straight line. What we want to do is we want to find the slope of this. So to find the slope of this, I need a straight line. So we're going to be drawing a line of best fit. So how do we do that? So you want to make a smooth line that best represents the trend of the data points. So when you draw the line of best fit, it represents as much of the data as possible. So sometimes it might go through the data points, sometimes in between. We try to have the same number of points above and below the line of best fit. So let's see what we can do here. We're going to draw a line. Let's start at 0, 0 and see what we can do. And look what we have. We're going to extend a little bit beyond here. Actually, it looks like that's a fairly good representation of the trend that I have. So that's all I did. So some points are not directly on here, but that's okay. So there is your line of best fit. Now what we want to do next is we want to find the slope. So when you're finding the slope, you're really looking at the relationship between the two axes. And it's going to give you more information between the variables involved. So what you do is you want to pick 2 points and far apart, not too close. If I have these, say I pick a point here and here, I can easily make an error here. It can be off a little bit, and that could be a substantial impact on my values. If I'm off a little bit up here, it makes no difference. So I'm going to pick these points and try to go towards the ends and make sure the points are easy to read. So I selected this point and this point on the line of best fit. Your points that you're using for slope must be on the line of best fit. I don't use the data point because most of the time the data points aren't on this line. So next thing I do is I want to show the x and y coordinates. So this value over here is going to be 0 and 0. And the x and y here, so the x is going to be 9 seconds, and the y looks like it's 47.5. So these are the 2 points I'm going to be using to determine the slope. So when you're doing slope, remember slope is equal to the difference in y, or the rise, over the difference in the x, over the run. So you always go like this, y2 minus y1, x2 minus x1. So remember, the change in the y is the rise, and the change, and the change in the x is your run. So something to keep in mind. So let's substitute our values in here. So I want to include the units as well if appropriate. So y are going to be the kilometers, the position. So it's always y2, so this is my second point. This is my first point over here. So y2 would be 47.5. And y1 is 0 kilometers. I want to include units and direction. There we go. And the x is going to be the time. So we're looking at 9 seconds for my second point, and my first point is 0. So 9 minus 0 seconds. And my slope here, when I calculate it, I think it's 5.27. So I'm going to round it a little bit, 5.3 kilometers. And I just noticed an error. This should be actually in hours up here. So kilometers per hour east. So that's my relationship. So it looks like that every hour we travel about 5.3 kilometers in this particular situation. And if you think about kilometers per hour, doesn't that sound like a speed? Well, when we have direction, that's actually called velocity. So we have the velocity, and use a short symbol v with an arrow on top. The velocity of the vehicle is 5.3 kilometers an hour to the east. So we understand how the position changes with the time. And the whole idea, again, with graphs is you have a lot more information by graphing. You can see it's a nice consistent increase we saw in the graph. So every hour we traveled 5.3 kilometers. And it's very hard to see it on the table, but in the graph, it's very, very easy to demonstrate that. So that's it. So what I'd like you to do is I want you to graph this data, make your own scale, make your own line of best fit, and determine your own slope, and then compare to what I have here. All right, that's it. Take care.